Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a complex number problem. As per the problem, write a polynomial equation with real coefficients that has the roots 2 and 1 minus I. I is the imaginary unit. We can find the polynomial equation by analyzing the given roots. The first given root is 2. This is a real root of the polynomial. The second given root is 1 minus I. This is a complex or imaginary root of the polynomial. As per the problem, we have to write a polynomial equation with real coefficients. As you may know, in a polynomial with real coefficients, complex roots always exist in conjugate pairs. A complex conjugate or conjugate of a complex number is an expression that has the same real and imaginary parts but opposite sign between the real and imaginary parts. The given complex or imaginary root is 1 minus I. So the conjugate root for this given complex root is 1 plus I. 1 plus I has the same real and imaginary parts as 1 minus I, but opposite sign between the real and imaginary parts. So this polynomial has two complex or imaginary roots, 1 minus I and 1 plus I. So in total, the polynomial has three roots. We can use these three roots to write the equation of the polynomial. We can start by writing the equation in factored form. Let's assume the polynomial can be represented by f at x. So the equation in factored form is x minus 2, that's from the given real root, times x minus 1 minus I, that's the given complex or imaginary root, times x minus 1 plus I, that's the conjugate complex or imaginary root we found. This is the equation of the polynomial in factored form. We can simplify this equation. The first step is to get rid of the inner parentheses. We should distribute the negative sign into the inner parentheses. I get x minus 1 plus I times x minus 1 minus I. Next, we can distribute the terms in the second and the third parentheses. We do x times x, then x times negative 1, then x times negative I, then negative 1 times x, negative 1 times negative 1, and negative 1 times negative I, and then I times x, and then I times negative 1, and then I times negative I. I get x squared minus x xi minus x plus 1 plus I plus xi minus I minus I squared. Next, we can combine like terms in the second parentheses. Negative xi and positive xi cancel each other out. Plus I and negative I cancel each other out. We are left with x squared minus x plus 1. As you may know, I square is equal to negative 1. So we can replace I square with negative 1. Negative x minus x is equal to minus 2x. 1 minus negative 1 is equivalent to 1 plus 1, which is equal to 2. Next, we can distribute the terms in these two parentheses. I get x cubed minus 2x squared plus 2x minus 2x squared plus 4x minus 4. We can combine like terms in this equation. Negative 2x squared and negative 2x squared are like terms. I get negative 4x squared. 2x and 4x are like terms. I get 6x and then minus 4. This is the equation of the polynomial. As we can see, this equation has real coefficients. So this is the equation of the polynomial with real coefficients that has the roots 2 and 1 minus I. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.